Okay, so we'll be talking about the new experimental QUIC driver today, and this is an exciting time. It brings back memories for me because I remember in graduate school, my professor went on to head up the IBFES 6 effort, but he hated TCP and all the problems it had. So he used to make us read research papers on why TCP had all these problems. And so this is like deja vu from like 40 years ago. 30 years ago, whatever, all the problems with TCP. Okay, so we'll talk a little bit about, QUIC, and then Xin Long at Red Hat had provided me some status updates on the driver. And then I'll talk briefly about the sifs.ko changes that are needed, and then what to look forward to. And I really welcome feedback here because some of you guys are experts in different areas of this, and QUIC solves multiple problems. Okay, so one thing we could do is ask ChatGPT why QUIC matters. And it was kind of amusing, right? Because when you ask it, it comes up with a couple reasonable answers. QUIC reduces latency, it improves multiplexing, but it's not perfect at this. Oops. I wasn't real impressed with its answer. It does improve security, but we already have this in SMB, and it does improve congestion control, and it is faster handshaking. But, yes, ChatGPT recommends we move to it as well. But for me, this is much simpler. If I was trying to save this presentation into the cloud, I want to avoid the problem of port 445 blockage. Spectrum, our internet provider, blocks port 445. And if I want to save this presentation and have multiple people editing at the same time, it's a lot easier if if we can just save it in the cloud. I can do that at Starbucks, I can do that at some hotels, but I can't do it here at home because the port's blocked. But it also is kind of interesting because we're in a paranoid security world. And in our paranoid world, it may help to have machine credentials and user credentials. It may help to encrypt multiple ways. There may be advantages to using QUIC encryption in some workloads. It may even be required. Now, the other interesting thing is I was talking to some of the Microsoft QUIC developers, and they mentioned that there was an unencrypted mode they used for testing. And that was of a lot of value for them because this unencrypted mode for testing was actually faster, right, than TCP. So it was kind of a fun thing, but it got rejected, I think, by the standards committee. But you could turn it on and for debugging mode and for testing mode. And I wonder if we could try something similar with the kernel driver, where you're not worried about encryption. It's still a bit faster here to use QUIC than TCP. And there may be cases where double encrypting is of value. Anyway, back to the original points. The things that sold me about QUIC when I first heard about it reminded me literally of graduate school and talking with, graduate courses in networking, when head-of-line blocking, congestion control, faster session establishment were well-known problems with TCP. And of course, the reduced retransmissions as well. The forward error correction is a nice feature of QUIC as well. But also just think about it this way, then the internet is moving toward QUIC, right? I mean, more and more traffic is using HTTP3 and QUIC. You can look at Google the stats on that. So having SMB move toward the future is a very good thing. We can already support RDMA. In the dark ages, we supported NetBIOS. I remember at an early Linux conference, maybe 15 years ago or so, I think there are some HP developers working on SCTP, and we hacked up a Samba change and a sifs.ko change to run over SCTP. And in retrospect, I wish we had merged that because that would have been a nice example. But today we support RDMA and we support TCP as transports. Adding QUIC, as long as it's a socket API, is not a big deal. Okay, but why don't we have QUIC on Linux? What's the obstacle? Well, we do have QUIC in Linux, obviously. We have user space drivers. I have a link here to the Microsoft QUIC driver, which is used by various workloads, but it's all in user space. The Microsoft QUIC driver is well tested. Obviously, the Google QUIC driver is well tested, but they only work in user space, so they're severely limited in what you can do. Windows has a kernel driver. We don't. So why don't we? Well, there's a couple of reasons. I remember talking over the last couple of years with with some of the Microsoft QUIC maintainers. I also talked with Ronnie and some others about this. And just many of the open source user space drivers just don't follow kernel code guidelines. They just would not port well. I mean, you could borrow some code, but you'd have to change 50% of the code to fit kernel style. And that's important, right? The kernel follows kind of strict guidelines for C style. Maybe we could write it in Rust someday, and some of the style would vary. But a year ago, not quite a year ago, about 9 months, 10 months ago, Xin Long at Red Hat with a couple other guys started a kernel project which is now looking very, very promising. And I want to go over that and talk about what we're experimenting with. And I think Namjay in his talk an hour or so ago mentioned that he's also looking at the same stuff, trying to figure out how we could leverage this driver in KSMBD. Now, is this just a Windows thing that we care about? Obviously, you can Google this, and you can see Ned's slides and Ned's blog entries on this. And learn.microsoft.com explains about how to set up SMB3.1.1 over QUIC for Windows. But remember that Visuality, and probably others, also supports SMB3.1.1 over QUIC. I think in Ned's talk, he has a link to the Visuality demo. So basically, Android phone using QUIC to connect to Windows and Azure. I think this is going to be a great addition for sifs.ko, ksmbd.ko, and as well as Samba server and tools. Now, here's an example from Microsoft page showing setting up QUIC. In Windows, it looks pretty easy. There's a little bit of obviously setting up, configuring the certificates, but you can see that doesn't look too bad. And there's a nice description of how to do this in learn.microsoft.com. But what also intrigued me was, if you look at Windows, they basically just have this /transport:/QUIC option. And you can see this example here, transport QUIC, and then they set up the certificate, then it works. So it really is very straightforward on Windows, it looks, to use. So hopefully in Linux we'll do something pretty similar. My idea would be to have we have a mount option today for RDMA. We could have a mount option today for QUIC, and I'll talk about that in a few slides later. Okay, I'm going to pause for just a second and see if there's any important questions I need to look at. Okay. Now, here's a diagram from, and by the way, I recommend looking at this. There's a talk by Obad from, I think this is STC EMEA a year or so ago, a couple of years ago maybe. And he goes through how QUIC works with SMB3.1.1, and it's pretty easy to follow. But as you can see from this picture, from the client perspective, it just looks like another stack, TCP or RDMA, SMB Direct or TCP. It just looks very similar from the SMB client perspective in Windows. And that's the beauty of this, right? SMB is sort of transport agnostic, and this is a very good thing. So, good news. This driver is making a lot of progress. Go to github.com, LXIN QUIC, download it. There's a nice README file you can see there. Very easy to install. Okay, so here's what I'm impressed about so far. Kernel style and code looks good. Very easy to build. They have a bunch of functional tests, easier to run. What I really like is that it's a reasonably small size. In user space, they do a lot of the code. So they don't, I mean, the kernel code is 10 or 11,000 lines of code. It's not, it's not bad. So I like that. It's fairly easy to wrap your brain around. And there's also a good set of functional tests, over 100. And maintainers have been responsive to emails and questions. That's kind of a good news, bad news, because I sent in an email asking some questions about 30 minutes ago, and he responded, unfortunately, because then I had to update my slides. Not always a good thing to have responsiveness, but the maintainers have been very responsive about this. Okay, so I had no problem building it. You can see here, this is on 6.9 RC4, but I also have a VM here where I've got it running on 6.5 kernel. Actually, I probably ought to show that let me show that briefly. Give me a second here to load it. Okay, and I'm just loading, sorry, I'm switching screens here, apologize. Let's see, share. Oops. Okay, so you can see here, this is, even on 6.5, it loaded fine. LSmod quick, modinfo quick, very easy. Okay, so let me go back to my slides. And share my screen again. Okay, so as you can see, it's very easy to build and install. So let's do a quick overview of the status of the kernel driver. And these slides are courtesy of Zinlong. He just sent me literally an updated version in the last half hour. He talks about the background, the implementation, the usage, and the next steps for the kernel driver. And the reason I'm focusing on this is that the SMB parts of it are, only a few hundred lines of code. They're not a lot. The largest parts are that 11,000 lines of kernel code that are in QUIC.ko. Okay, so what is QUIC? Take a look at RFC 9000. I think that'll give you additional information that'll be helpful. QUIC is not TCP based, it's UDP based. And as a result, it avoids many problems with TCP that have been known for many, many years. It supports multiple streams. They use TLS 1.3 for the security and encryption. There are, a set of at least 7 or 8 RFCs there that can give you more information on specific pieces relating to this, but it's well documented, well used, and obviously a significant percentage of the internet traffic runs on it. Now, there was a call, I remember last year, and it sounded like we had 2 or 3 kind of immediate users, SMB being the first, that were strongly interested in it. And then obviously there are many people who would much prefer QUIC to sort of the NFS approach there right now, where they're playing with TLS for supporting encryption, because QUIC solves multiple problems, not just one. And it's easier to focus on QUIC rather than drivers using a mix of hacks for this. It does sound, even examples like AFS, right? They would like to experiment with this once they see other drivers moving to it. But I think you'll see multiple kernel consumers, not just SMB, interested in it. And that's what the feedback he's getting as well. The socket APIs are pretty easy, right? I mean, we have a listen, accept, connect, send, receive, close, get socket options, set socket options. These are very similar to TCP, and they make it pretty easy to do the SMB code that's needed. And obviously, being able to support send file and zero copy is nice. One of the priorities that he's been experimenting with is how to offload to NICs, similar to the TLS offloading today. And also remember that in the SMB world, we obviously with RSS we get offload of the TCP part of it, and then we also can get offloading of the encryption when we use SMB3.1.1 encryption. And it's kind of odd because encryption was faster than signing for a while because of that offloading to NICs. So this is an important feature to discuss later. And it is also very helpful when we have a single driver in the kernel that has lots of eyes, automation going on all the time. I get emails from automated bots that are analyzing kernel code every week. We have a lot of userland QUIC implementations, not just MS QUIC and Google, and that gets distracting. It's always helpful to have an authoritative version in the kernel. We see that in multiple cases, and there are sometimes performance advantages as well. Being able to do send file is important. Being able to offload to NICs is important. These performance features are much easier in the kernel and much safer in the kernel. So in kernel QUIC doesn't mean crypto offloading for userland QUIC. So here's some history here, the evolution. When the TLS handshake came in, and I think this history gives you some idea that there is a push toward some of the requirements that QUIC is going to help solve. Okay, so what's the general idea we're talking about here? We have an in-kernel QUIC with the handshake done in user space. There's no point in doing the non-performance sensitive pieces in kernel. We want to make the kernel part those pieces that are most important for stability, most important for performance. And obviously we can do the handshake in user space. So he explains here why the ULP layer is not used. And the kernel consumers use the handshake netlink to request the handshake. So here's a picture of the architecture. So he has in his project, TLS utils user space thing and libquick. And you can see the pieces that are in user space here, and the pieces, the upcalls for the handshake. I'll leave this chart up for a minute so you guys can digest a little bit of the high-level picture of how this is structured. But note that you have a mix of kernel code and user space code. User space doing the handshake, the SMB driver having to upcall to KTLS utils, but only briefly. And the API that the SMB driver is using is very simple. The API is just the socket API, but IP proto QUIC. From user land, this is what it looks like. From user land, send, receive message, set, get, sec, doesn't look much different. Okay. Now, here's a picture of what the socket process looks like. I'm going to leave that up for a second so you guys can kind of digest that picture. Now, obviously, you could be using it from user space. This is what it would look like. Socket, pass in IP proto QUIC, get a socket, bind to the socket, connect, do the handshake, then you can do send message and close. On the server side, if you're trying to receive this, create the socket, you bind to it, you listen on it, you accept the connection, you receive a message, you close. Accept the message, do the handshake, receive message, close. This is very easy to use. And in fact, it looks actually easier to me. Maybe I'm prejudiced, but it looks easier to me than the TLS example. So to me, from user space, this looks quite simple. What I don't know, and I don't have any data on right now, is what the performance looks like for that. But inside the Git tree, which I posted, it's earlier here, but you can see it here, github.com LXN QUIC. There's a sample program to test this from user space if you want to do an experiment. There's also a sample in the kernel. So from the kernel driver, it's also simple, right? Sock create, IP proto, kernel connect, send message, release. So it's a very simple change on the SMB side. Now there are advanced APIs. There's send message that allows you to set the stream ID and receive message that lets you get the stream ID. There's also socket options for rekeying or updating the key, which was something I had meant to ask them about, because I think that's getting more common, where we rotate keys, change them periodically, and changing them on an active session. So here we have socket opt key update. Connection migration, another feature that, at least for the Azure case, is important as you move connections. And then stream open, reset, stop sending, and sock opt session ticket. There are also notification events on connection update and stream update. One of the things I meant to ask them about, and I want to follow up after over the next few weeks about this, is the dynamic tracing and eBPF type management for how you monitor events that your debug tools may need to be aware of in the QUIC driver, session disconnections, that sort of thing. There's a man page here that explains it more, and there's examples inside the test directory. Okay, so what are the next steps? Offloading crypto to hardware, right? So we similar to SMB, where encryption can be faster than signing because we're offloading it to the card. And then there's this internet draft for QUIC sockets API extensions. Okay, so in the recent email we were exchanging, he mentioned, why is kernel QUIC useful? Because it enables use for kernel consumers. Well, the SMB driver, zips.ko, is one of those. KSMBD is another. It sounds like there's strong interest in multiple other kernel drivers. And obviously there's a lot of pushback on NFS using TLS, so this may be helpful for NFS as well. What I like about it, it's also easy to understand socket APIs: listen, accept, connect, send, receive, close. Being able to support send file, right? The data copy from user to kernel, being able to support send file is a big win. And it's easy to cooperate with offloading and NICs, no configuration needed from user space. And obviously less interoperability issues for QUIC and the OS if it's user space. You don't have to worry about weird changes. The QUIC kernel driver, if there's a global kernel change that changes some function call, well, the QUIC driver will get that too. Okay, so what's next for their driver? So one of them is improving performance and completing the congestion control code. There's some testing data versus KTLS in the GitHub README. He was collaborating with Andy from Broadcom to implement infrastructure for offloading inside hardware NICs. And he's working with another colleague to start an RFC doc for standardizing the socket API for using QUIC inside the operating system. Okay, now what about
Steve,
our pieces?
Can I comment on this?
Sure, absolutely.
So, yeah, what you see there is the LPN thing that needs to be implemented in the server side correctly. So because web servers, SMB server, NFS server, I guess all are bound to UDP port 443, and with the current API, that's not possible.
Yeah. So this ALPN, just to clarify a little bit, This is an app layer protocol negotiation ID. Do you know how big a change this would be for Samba, let's say, to use this?
It's trivial.
Okay, I thought it was trivial, but I haven't seen the actual code where we'd set this. And also, it's something I guess Namjay has to think about for KSMED. What's your
No,
thought about? Is there any changes needed on the client for that?
the ALPN thing is a thing that needs to be changed in the QUIC driver in the kernel.
Ah, okay, yes, okay, got it. Um, and on the SMB side, it actually isn't too bad. I was looking at, okay, we have a negotiate context to parse called transport capabilities. There's one flag in it to parse. And then basically it's just a new socket type. And, Mets or others, if you see other things that I'm missing, this doesn't look huge. It may be a little bit tricky with multi-channel, how we advertise it and how we consume it. If, for example, you had some channels over QUIC and some not, but I hadn't looked at that yet. But basically, the negotiate phase is trivial, and the socket API looked trivial. What I was running
Yeah,
into recently, of course, was other bugs that sucked up my time. But it's one of those things I plan to work on this week, and then keep communicating with Zin on this. So there was some feedback from Dave Miller and the network maintainers. It looks like initially we were planning on putting it in my tree experimentally because there's no particular reason, I mean, to expose it to the whole kernel until we've tested it. We can put it in as experimental for my driver. But it sounds like from their review perspective, they prefer it inside the net tree. So it looks like it'll go in instead of SMBFS common initially, it'll go in net QUIC directory. And Zin's tree is easy to build and install as a module. As you can see, I built it on both 6.5 and 6.9 with no problem, 6.9 RC4. The code change for transport.c to do the read and write of the new socket type looks small, and something I was planning on working on this week and next. And then the same thing with the code to process the new transport capabilities negotiate context looked pretty small in SMB2 PDU.c. Okay, so there is good information in MSSMB2 about these. And there's also, like I said, Obad's presentation and others that go through this pretty carefully. The things I wasn't clear about, and I'd love some feedback, and Mets, maybe you have some ideas, is what about user space tooling? Are there updates to CIFS utils or WinBind or Samba tools that could make the certificate configuration easier? Or obviously we could have a new mount option to force use of QUIC, but are there things that would be helpful in CIFS utils or Samba or WinBind that would make this easier?
yeah. I mean, what the important thing that's needed is that we need to currently we just print out IP addresses without port or without saying it's TCP or
Yeah.
whatever. So the output of some comments will change, or the input parameters and so on. And yeah, that's a little bit of work, but the low-level changes should be very trivial.
Yeah, I mean, what I love about this is that the amount of code is small enough in kernel that this doesn't seem like an enormous risk. The benefit is obvious. Obviously, we get sucked as kernel maintainers, as Jeremy and others were mentioning, right? I mean, dealing with complaints about stable or bugs that take our time. So we do encourage any code contributors that want to play around and experiment with this. It's a very exciting time. Now, what I'm most concerned about is testing. And so one of the things I wanted to talk about is, okay, so how do we test this? I think there's a couple areas that are worth mentioning. There's a test subdirectory of the QUIC GitHub tree. From the SMB perspective, the normal XFS test should be fine. We just need to have a local config that specifies the mount option and find some target servers. Worst case, we can test against Windows. only, but I think as Samba and at KSMBD add support, we can exercise that code on every check-in, right? The same we do with XFS tests today over TCP. We will need to try various encryption options, though, cases where only QUIC is exposed and where both QUIC and TCP are exposed, where you're encrypting two ways, where you're encrypting only one way. I'm sorry, one way as in like you're only using QUIC encryption or only using SMB3.1.1 encryption, but we also probably will have to test the cases where both encryptions are enabled. Now, the functional tests are huge.
Steve?
They've got 192 functional tests. I ran them. At the moment, I'm missing a dependency for, I can show you the tests running, but they fail about 150 tests in or 100 and something tests in right now because I'm missing a package on the VM I set up. But 192 functional tests, they seem to do fine. Then when that finishes, they run perf tests, and it's trivial. You just CD test, make run. They did a good job on this, and you can see they test the logical things.
So, Steve?
Yeah.
At least for the Samba server, most of the tests actually aren't done over TCP. They're done using socket wrapper. And so I was wondering, yeah, it actually emulates a full TCP connection. I was wondering if socket wrapper, Andreas is on, maybe. I wonder if socket wrapper is planning to add QUIC support, or at least emulated QUIC support.
I mean, that's a very good question. I think, when you think about SMB torture, and I'm also kind of curious how the Microsoft functional tests, remember at a lot of the test events, how the Microsoft functional tests test the SMB over QUIC. In my particular in XFS tests, worst case, I'm running localhost, but I could do localhost over QUIC. That wouldn't be hard. But yeah, this is a very good question. But I was very impressed with the functional tests that they have set up. And they also were looking at, if you look at the README file, they have some good discussions about testing against other QUIC drivers, like MS-QUIC, for example. So Linux to Linux, but Linux kernel driver to Linux user space drivers. And I think setting up automation, here's the example of, test run from a couple of days ago. This is current mainline, KSMBD, right? Running to Samba, running to KSMBD over QUIC is not going to be a big change. What we're going to see in that example is, instead of the config file name KSMBD or KSMBD with, I don't know, sysacl, we'll have a KSMBD QUIC local config, and then run at least 2 or 3 tests on all check-ins using that. Obviously, all these are run over TCP at the moment. We also need to do some improvements, and I would love some help from Tom Talpe and others on making sure we're regularly running with RDMA, SMB direct, because I think it's important that KSMBD, Samba, whatever. I mean, we need to run as many targets as possible with RDMA as well. Okay, so I do want to show briefly. Let me see if I can share screen briefly. Okay, so if you look at so here's the QUIC code. You can see last update April 9th, and you can see that the Zinlong, who's been emailing me back and forth, is one of the main contributors and doing a great job with this. What I love about this is I can just do make run, and it kicks off very easy to run functional tests. Now it will fail as we get to the end because I'm missing a package, but on this VM, but it does a bunch of handshake tests. It does a bunch of connection tests. And also, I'd be very curious if Metz or any of you guys have any work in progress Samba branch you want me to look at to play around with that uses any of the user space QUIC drivers or the kernel one, either one. So I can make sure I play around with that as well as I finish up the Linux client stuff. You can see these handshake and stream tests. and then it kicks off the performance tests. Oh, actually, maybe I fixed that. I may have added the missing package. Sorry about that. But you can see that these are very good for a 1-year-old project. I was quite impressed with the work those 3 guys had done. Actually, am I sharing that properly? Let me see. Okay, so okay. So here's some links of things to explore. The GitHub project, obviously Alex and QUIC. There's an alternate open source implementation user space that's well tested, MS QUIC. There's the GitHub tree. I've talked with those maintainers. There's some nice posts and blogs by Ned on QUIC, and also links to the other third-party implementation. The SNIA presentation from Obide, I think, was useful. And also learn.microsoft.com has a nice walkthrough on setting up QUIC. I think these resources are very useful. I did have a couple requests for like, hey, where's a good TCP, where's a good networking textbook that explains QUIC at a, graduate school level? So if anybody's aware of that, let me know, because a couple of the people that reached out to me needed to ramp up on layer 3 and layer 4 networking protocols, in particular QUIC. These resources are good, but if you guys are aware of specific ones that could help educate some of the people that were interested in contributing but didn't know enough about QUIC, let me know. Okay, so I think we've got time for 5 minutes of questions or something. So anybody have questions? Any questions we can answer?
Hey, Steve, you mentioned my name.
Yes, I would love help setting up automation for RDMA testing.
Yeah. Okay.
I think you did a lot of useful stuff on that, and then it got buried under other bugs. But one of the things that I think may be helpful with QUIC is if we're testing on alternate transports, it may be that an SMB direct test could come up with a bug that affects
Yeah.
other
No, it's
transports.
definitely possible. And there are 2 software providers that should work in cloud environments, etc. Even if you don't have a hardware adapter. So those are all possible. I do those for my home testing. I mean, how do we engage?
Yeah, and well, let's
You want
follow
me
up
to
with that.
just do it? That's kind of a challenge, right?
Yeah, I mean, I
So,
think basically what I needed a little bit of help with on that is setting up soft iWarp or whatever it is, the easiest way to do it.
yeah, it's easier now than it used to be. It was a real pain in the ass about a year ago. It's been fixed a little bit.
And I think that'll help reduce risk. And the other thing that I was thinking about in the back of my mind is, should we revisit? It turns out, if I remember correctly, Xinlong is also the maintainer of SCTP. So I asked him, I don't remember
Yeah.
a whole lot about this, but we supported it in some demos 20 years ago or 15 years ago over
Steve, I don't see the
SMB1.
point of supporting SCTP in the client. There aren't any servers.
No, I mean, but it would be one of those things that would be fairly easy to hack. Back then, what we did, I think, with an HP guy, or I forget who it was, but it was fairly easy hack in Samba and fairly easy hack in the client.
Yeah, SCTP, it works like a socket, so it's not so bad.
Yeah, I know what I was getting at is that if there's cases where SCTP is of value, because there are a couple examples where it's better than TCP, it might be easier to set up than QUIC. One of the things that scares me about
Steve,
QUIC,
that's been the question of SCTP for about 20 years. Where is it of value? And
Yep.
the answer is not many places, but okay.
Yeah, the thing that scares me, and the reason I revisit this thought from 15 or 20 years ago, is that certificate setup may be an obstacle for people. And if the IETF guys push back on unencrypted QUIC, right? Unencrypted QUIC is used for testing today, right? So you can run various drivers without encryption. But if it's impossible to do in practice, and there's cases in, I don't know, clusters or whatever, where you literally can't set up certificates because of some limits, just the number of certificates and the way it's handled, and you don't care about encryption, is there a case where something other than QUIC has to be used because of the politics involved in supporting unencrypted QUIC?
I don't see the point of unencrypted QUIC, but okay.
Well, I mean, my reason for this is that if you have a secure network, it's faster than TCP.
Yeah, QUIC is all about using it on the web.
Well,
Security
it is
fundamental.
today, but my bigger point is, if it's faster than TCP, you either invent a new protocol or you use unencrypted QUIC if you're on a secure network. So if your goal were to transfer data the fastest possible between two nodes and it was a secure network, why would you use something slower?
So if that's your goal, why would you use SMB at all? Why wouldn't you just use a dedicated, highly optimized block protocol?
I mean, you could, but then you run into the problem of you don't see the I/O patterns the same, and you don't have.
Isn't SMB direct exactly for that case?
Yeah, I mean, it is, to be honest, and I think that what I'm expecting someday is that there'll be emulation of SMB direct, even when there's no physical RDMA hardware.
Well, there is. That's what the soft RDMA providers are. There's two in the Linux kernel, or at least
But I guess what I'm getting at
is,
is, would they be faster than TCP? I mean, QUIC's beauty is it solves 4 or 5 performance problems in TCP.
Bernard Metzler at IBM Zurich has discovered that soft IWARP is in fact faster than TCP.
Okay, well, that's precisely
the
the thing I'm interested in on this related topic of what do you do on the fastest networks. And by the way, on the thing about a block driver, I mean, there's nothing that would stop SMB being used for a block driver. We had code for that at one point. SMB as a block driver protocol would be fairly easy.
Steve, I'm just trying to be skeptical because, it's like you could do a million different things, but only some of them are going to be interesting on any sort of broad scale.
Yeah, what I love about this is it's easy, relatively easy, compared with some of the other things. I mean, as an example,
for a developer, I don't think it's easy for a user.
But generally, sorry to interrupt you. I guess this could be going on for several hours.
Yeah,
it's a very.
Well, let's go on to the next talk then. But
Yeah.
I really would appreciate feedback from you all, and especially any progress on Samba on using this driver or KSMBD.
And Steve, I promise to whip you up some sort of easy how-to for soft RDMA providers in Linux.
Yep. And I want to give a big shout out to the 3 Red Hat developers I call out earlier in the talk for some excellent work here. Okay.